Hi, everyone. Thank you for joining. My name is Caroline Griffin. I am Riot's Events and Operations Manager. I am super excited to have Kiefer and Fiodar here from Klarrio today to talk about distributed monitoring of microservices. Just a few quick items before we get started. If you have any questions, please do put those in the chat box. We will make sure all of your questions get answered at the end of the presentation. And this will be recorded. So if you missed the beginning or the ending part, do not worry. We will make sure you get a copy on the meetup page and Riot's YouTube channel. And Fiodar has already shared the presentation, so we will also make that available on the meetup page after the presentation. But without further ado, I will let Fiodar and Kiefer get started. Thank you all for joining us today.
All right. Hello, everyone. So my name is Fiodar Zboichyk, and welcome to this presentation. We'll talk about monitoring of distributed software systems. So let's go ahead. The next slide will quick agenda. The first part I will talk about, we'll make some definitions, what monitoring is and what it isn't, where it belongs in your system, why you want it, things you'll probably have to think about if you start doing it, and how to get started. The second part, Kiefer we'll talk about how we do monitoring, what tools we use. We will, and kind of the different options you have and maybe more challenges you run into when you do it your own. And that's it. So let's go ahead. Who are we? We're Klarrio. We're a professional services company. We're a system integrator. We rely heavily on open source technologies to create solutions for our clients. We focus on data streaming and data analytics. On the left side of the picture, you can see where we came from: IBM, Technicolor, Alcatel, SPSS. And there's some of our clients. The little K in the circle is where our offices are. We have a US office, Australia office, and a few European countries. And some of our clients, the KPN in the middle being the biggest client, they're Dutch Telecom, that we build a data streaming platform for. And I am CTO and one of the co-founders of Klarrio US. And Kiefer is a site reliability engineer who runs that data streaming platform for the Dutch Telecom with a focus on monitoring. So why you would need monitoring, or why you would do that? This is one of the approaches to it. I would probably call it a reactive strategy. When things go wrong, the users will call me, and I'll see what I can do. If you're a fan of the IT crowd, there's a picture for you. More of a proactive strategy. Let's define what monitoring is, what it is we're talking about. So on the next slide, when we say monitoring, what we mean is the collection. We're working with the metrics that are numerical, so it's always a number, and it has a bunch of labels associated with it. So the whole process of collecting it, storing it, processing it, and analyzing it is what we call monitoring. The metrics you can think about as infrastructure, like CPU usage, memory usage, disk usage, bandwidth of your networking infrastructure. The applications, whether it's something you wrote or some open source components or commercial components that you use, they have their own metrics. Number of requests, maybe average time it takes a request, the message size, whatever is applicable to the application. It's important to say that these metrics, they have labels, and you always end up aggregating. So let's say you count the request. You don't report metrics on every request. You kind of keep track, and every now and then you report either the cumulative number or some average number. And using labels, you can aggregate them together. Once you start doing this is too much data to actually understand, but what you want to have is, let's say, a dashboard or something that you can take a quick look and see if your system is doing good. So you want this higher level view where you aggregate things like over your nodes, over your applications, over your system. But then if things are not doing well, you want to drill down and find what service is using too much CPU that you've seen on the higher level dashboard. You want to have live data, pretty obviously, but you always want to have a historical data as well for troubleshooting or analyzing what was going wrong. Where it started, when it started. So that's what we call monitoring. It is part of what we call observability, which in control theory is the flip side of the controllability. And it's defined as knowing the state of the system, the internal state of the system, by looking at its outputs. So this is our SRE workplace. No, wait, this is Airbus A380 workplace. It's very easy to confuse. So you see, they use dashboards as well. With the hard data feeding into that. I'm no pilot. I did play with the Microsoft Flight Simulator a little bit, the old one. And I was a bit disappointed when you have this virtual cockpit and you just kind of almost like looking out from the airplane. The window is really small where you can look out and see the trees and see this. Most of the space is taken by these damn dashboards and instruments. Probably because they're a much better way to control the aircraft and understand what it's doing than just looking out the window. And I hear the pilots can land the airplanes in the dark, in the fog, no visibility, in the correct airport, using just the instruments. So when you run your software system, you want the instruments as well, driven by the hard data, to understand, how your system is running and do you need to take corrective actions. So in the software world, by observability, we usually mean these four things. And there's logging, is what everybody knows, and it's probably the lowest level of details, the most details that you get. So logging, you deal with events, whether good events, bad events. You can have data associated with events, but you record every single event. Somebody connected, something crashed, something happened. You can aggregate logging in some fashion, but in the end, you end up, that's where your last sort of level of defense when you do troubleshooting. In the end, you go to logging, but you want other tools to find the right place, because it's every single event. To find the right place is a little bit difficult. I'll skip the monitoring. Monitoring is what we said. This is aggregates of the metrics. You don't record the count on every change. You aggregate, so you have a little bit higher view. Tracing deals with latency. So before distributed systems, you probably didn't even need tracing, because it's all one monolithic application and you can do away with monitoring and logging. When you have 100 microservices, and you end up in a situation when the request takes 2 minutes and every microservice responded within 1 second, what did the time go? You want some tools to help you with that. Where did the time go? So tracing is measuring latency in the distributed system. And the way to do it is you sample, let's say every second or every 100th or 1 in 1,000 message, you trace as it goes through the system, and you record time in your tracing system, and then you can see where the time is spent. Assuming that if something is wrong, that one of these traced messages, 1 of 1,000, 1 of 100, will show where the problem is. Alerting is really an aspect that belongs to all three of them. You're collecting too much data, people cannot watch it, to sit and watch 8 hours. It's impossible. So you need computer to watch it, and you want it to alert you when something goes wrong. And this is a bit of a medieval art. You don't want to miss anything important, and you don't want it to be the boy who cried wolf. Because as soon as people start ignoring alerts, you don't have alerting, right? Maybe it's not an important alert, and then next thing they ignore important alert. So you need observability to be able to run the thing. Let's see where the observability belongs. So next slide, I think it's getting popular, the notion of a control plane. Really comes from the networking world. The networking devices, I guess a long time ago, they were logically and maybe physically separated into data plane, where the user traffic is flowing through. The control plane that deals with signaling, so not user traffic, but sort of devices talking to each other, routing tables and whatnot. and the management plane where you go in and you manage the devices that way. So the software people said that's a nice separation of concerns. Let's borrow that. So they took control plane, management plane, sort of mixed it together and says this is our control plane for our software systems. So they didn't borrow the data plane notion, but basically that would be the functionality, the primary function, the business function of the system. If it's a financial transactions or medical documents, retail systems, video conferencing, this is the main business function. Control plane deals with, let's say, the rest. Nowadays, you have infrastructure as a service, a lot of infrastructure as a code, and a lot of things as a code. So you keep configuration of your infrastructure, your applications, your dev test stage prod environment, and these environments in our experience tend to grow like mushrooms in the forest. Next thing you want is sandbox environment, and then you want load test environment, and there will become too many to manage them individually. Once you have this configuration, you want the tools to deploy it on-prem or in the cloud or both, apply updates, rollbacks too, hopefully not. Scaling up and down, whether it's automatic or manual. If it's automatic, you still probably want the manual override. Backup, restore, disaster recovery, rerouting. You need these tools to run the thing. As soon as you say you run the thing, you need to observe it. You need to have the information to base your decisions on. So that's where observability belongs. Reachability, sometimes called black box monitoring, but it's not the monitoring we're talking about. This is, think of the DYN, the big DNS provider DDoS attack in 2016. I happened to watch a Slack channel. Slack was not affected for some reason. Slack channel of a support team of a certain product, and they were going a little bit crazy. Customers complain they cannot connect to our service, and our service is doing just fine. It's just they cannot resolve the DNS name. So, well, send them the IP address. And somebody says, okay, I'll go tweet our IP addresses. 10 seconds later, the Twitter is down, not available. Same thing, same problem, DNS doesn't resolve. So the system was working great. All the monitoring, all the logging, everything will show it's great. From the inside, it's just not reachable. If your control plane is separate from the system, well, that's a place to put the reachability test as well. So that's where your monitoring rolls up to. Let's say I convinced you, yes, if you want to run the system, you need monitoring. You can collect those metrics. You will probably run into these questions that I cannot answer for you. You'll have to think about them. Do you collect everything? What do we collect? What kind of metrics? Hopefully the components you use, excuse me. The components you use provide some metrics. Let's say you use Amazon Web Services. Their services come with built-in monitoring and metrics. You can add your own for extra money. You can collect custom metrics as well. So you have to decide, what's important. And if something is not important, what if we, a month later, we'll find out that it was important, we didn't collect it. How often do you collect it? Is it every second, every 100 milliseconds, or every 5 minutes? And reporting and collecting and reporting may be a little bit different. Maybe you collect them often, but you report not as often. So for example, AWS by default, out of the box, you get average over 5 minutes. So again, metrics are always averaged. The average over 5 minutes, if you pay extra, you can get it up to 1 second, which is pretty good, but it costs money. Do you store everything? And how far back in time do you store? And if it gets too large, can we go back and still store the old data, but maybe not as fine-grained, not every second? Can we do that? Or do we want to do that? Who makes sure the monitoring is doing well? Who monitors that? The dashboards, all these, the system of having a high-level view and then the ability to drill down. You need to kind of answer that, what dashboards are good. Alerts, as I said, this is a whole another discussion. How do you deliver? Pagers? Anybody remembers what that is? Who do you send it to? Can we send it to the US office during the US hours and Australia office to the Australia office hours? Is it just a Slack message? And how do you know that people saw it and reacted to it? And if nobody reacted to it, How do you escalate the alert? Because we assume it's important. Who gets it next? So this you will have to think about when you start doing it. And next slide is, you will think this is hard. And correct. That is the correct answer. So all the cloud providers, worth of their salt, they provide monitoring out of the box. All right. So AWS, Azure, Google, everybody, they have monitoring. If they don't, for some reason, or you want to be cloud agnostic, or you multi-cloud, or you have on-premise, like you augment on-premise with the cloud, or just only on-premise. There are third-party systems, too many to mention. Datadog and Sysdig are the two we used, and there's tons of others. These are, cloud-based offerings. You install agents. They will, hook up into your infrastructure and application, and will report metrics. And these guys, they probably solved a lot of these challenges, or they have guidelines. They can help you to answer some of those questions. Or here's how we do it. AWS, we store for 15 months. That's pretty good. So if you want to get started, go ahead, use one of these services, hook them up, and start doing monitoring. And you say, well, we want to do it ourselves. If you think you need to do it ourselves, you really need to ask why. What is the reason? We want, usually buy versus build. In many cases, buy is cheaper and it's much quicker, definitely. But things you can look at and say, well, I have to own my data, because it's your data. The monitoring is your data. You hook it up to the service, they ingest it, you have access, you have dashboards, you can drill down and find, and then you say, can I get 1 year worth of my monitoring data? It's my data. I want my data science team to go at it and see if they can do predictive maintenance. And they say, well, it will cost you to get your data. So is it really your data if you have to pay to get it? Same thing as security access. You would expect them to have good security. I would expect them to have good security. But you could have different situations. Let's say the streaming data platform we built for the telecom company, they use it as a part of a project in a larger consortium organized by the government. And as soon as you say that G word, government, regulations start popping in like quantum particles out of nowhere. So CISO of the telecom says, we need to control the data, we have to store it, we have to manage it, it's ours. And CISOs are people who are really difficult to argue with. They just say, my way or highway. If you need 100% on-prem solution, well, you can't really use cloud if it's 100% on-prem. The total cost of ownership is always tricky, right? Buy versus build. To start with, these cloud services, they're usually great. You start quickly, they're cheap. But sometimes when you get the production volumes, you get the bill and you go, how much? How did that happen? So, you need to see what your use case is and how much data you collect. We have, 500,000 metrics, I think. I don't know if we would be able to have that many if we were using a third-party service. Data granularity, that is kind of interesting aspect. Again, it's your mileage may vary. Our platform has an SLA for the latency. The message comes in and gets delivered to the recipient. That time should be no more than a quarter of a second. So we're running some tests, and we see some messages take longer. They don't meet the SLA. It takes longer than a quarter of a second. So monitoring to the rescue, we went and started looking, and everything's great. It's all fine. It's all green. Nothing is wrong. Nothing's going on. But we do see most messages are fine. Some messages are not. So ended up being very short spikes of some resource usage that impacted the message delivery. So the message were waiting somewhere. And again, 250 millisecond. It was enough to break that. And the reason we didn't see it on the monitoring is because they were averaging things out, and over 30 seconds, a minute, 5 minutes, the average was okay. because those averages are tricky. It's like when Jeff Bezos walks into a bar, everybody in the bar becomes a billionaire on average. So you have to look at your kind of use case. Data retention, you get AWS 15 months, pretty good. Who knows, maybe you have one of those regulations that says you have to keep it for 7 years. So some use cases that may impact these answers, let's say you have usage-based billing. Well, metrics is exactly what you need to figure out the usage. So may impact the some of these answers. Our platform, we actually have tenants that can run their own Docker containers in a sandbox-ish environment on the platform. Very quickly, they will be asking, what's my CPU? What's my memory? Can I use custom metrics? So we really should provide monitoring as a service from the platform to the tenants. So you need to know how to do that. It may get a little tricky to, I don't know, what do you do? Set up a Datadog account for every single tenant, ask them to do it. So if you do it yourself, you know how you have it, you manage it. So this could be the reasons, and quite a few of them, of these questions, they sort of checked for us. And we did start with the third-party services in the cloud. We like to use services when we can, but we realized we have to do it our own. And so we said, Kiefer and some of the others, can you get us some monitoring? Kiefer?
Yeah, so hopefully Fedora has convinced you by now that you need to roll your own stack. So where do you start? Well, we started by breaking out our binoculars like these guys. And we quickly found out that that wasn't the way. And so where do we go from there? Well, you start at the source. You start by ingesting metrics about your services. And we used Prometheus. We still use Prometheus. And this service ingests metrics from targets that you define in a configuration file, which I will show you in a minute. It scrapes targets over HTTP, whatever is in your configuration file, whatever Prometheus knows about. So it's a pull-based system. You can also push metrics to it with another component, or it can do it natively. It depends on your architecture, your environment. It ingests these metrics into an in-memory time series database. So it's really efficient. You can hold a lot of series in memory. We have 600,000 metrics, which is not that many. It may sound like a lot, but that's over 5 or 6 platforms. Some people have more, which I say is why it's not that many. But so you can hold a lot in memory, but it occasionally will dump these to disk, and you usually are backed by a volume. That can create some issues, which we'll see later, how we might be able to solve those. And each of these series is labeled with usually text-based labels for telling you more information about your metrics. So where's the environment where this metric is coming from? Is it dev? Is it your staging platform? Is it production? Could be, who ran some task that you're gathering information about. So things like this could be a host name. Very useful for aggregating, figuring out what you're looking at, or comparing across different labels, different environments. Prometheus also gives you a built-in query language. So you can say, give me this metric. I'm going to select this label, and it's very powerful for, you can do some math on your metrics just natively in Prometheus. Aggregation, you can do joins, stuff like that. So it's very a useful tool. And you can combine this with their API for pulling data with their query language, and you can get data back in JSON. So you can have a look at a range of data or an instant data point. Maybe you're quickly pulling something out to make a report, or hopefully you're not doing data science. You maybe find another way to get bulk data. And there's also some management stuff in the API as well. So reloading the config, shutting down, checking if it's healthy, stuff like that. So with Prometheus, you get, in just running one component, you have a pretty full-fledged monitoring system right out of the box. And it's fairly simple. The configuration language right here in less than 10 lines, this is telling you, hey, I'm going to scrape my targets that I have defined every 15 seconds. This can be, you can change that 1 second, 5 seconds, whatever you like. And they can be defined by a job. So what this is saying here is we're scraping Prometheus, and it's in a static place. We're assuming we're running it on our local machine at port 9090. Prometheus has some built-in service discovery that you can put here. So you could say, go to this DNS address. Maybe we use Marathon. So you say go ask the masters about the slaves, or ask them about these services we have listed here. You can also have some other component write to a file and say, hey, just give me everything in this file. So it's a pretty powerful tool, and it's fairly simple to configure. Now, once you have your data, you probably want to look at it and see what's going on. So for that, we use Grafana. This is a pretty common combination, Prometheus with Grafana as your visualization engine. It's written in JavaScript. It has really nice dashboards, which we'll see in a minute. And it can handle a variety of backends. So we're using Prometheus, but you can also bring in, CloudWatch. You can bring in those Azure metrics that Fiodar mentioned. You can even hook it up to Postgres or some other time series database. There's tons of backends that Grafana can handle. It also provides alerting capabilities. So while this may not be the best long-term solution, it does provide a quick way to get started with alerting. And it's fairly easy to understand as well. And all the major players are there. You have Slack, Microsoft Teams. You can send an email. There's, again, tons of different options there for your alerting. It also provides user management, basic auth. It can hook into OAuth as well, and it has some nice plugins that you can use as well. So let's have a look at a sample dashboard. I'm going to stop sharing quickly and reshare. All right, so this is Grafana. We're looking at our development cluster, so hopefully nothing weird pops up. Sometimes you'll see weird stuff on dev. But this is an example of a Grafana dashboard here. We're looking at, I showed you the configuration for scraping Prometheus as it's scraping itself earlier, and these are some of the metrics that you'll get. So you can have metadata. This is showing the version, and I guess probably a hash of the version that Prometheus is running. How long has the service been up? So we've been up for 14 hours. We relaunched, I guess, the morning, probably of the EU time zone. We're showing here the number of time series that we have. Dev's a smaller platform than some of our other platforms, so we're about 200K here. So you have some metadata, you have some information on ingestion into the system. Also have, let's see, resources here. Yep, there we go. So we've got how much memory we're using. Looks like we're around 2 gigabytes. CPU is pretty low. No one's making tons of requests right now, so that's good. You can also see information about the API that I mentioned earlier. So with Grafana, you can have some nice looking graphs that give you a lot of information. We have probably over 20 dashboards now that dig into our core components and some pre-built exporters. So let's talk about that. I'll show you a picture of our infrastructure. I'm going to switch over again here. Or maybe I can just do, no, I'll stop share. All right, so we're back. So let's talk about the simple setup that I've described to you with Prometheus and Grafana. So on the left side, you see your custom component running in a Docker container that's running on an operating system. So custom components, you'll have to write, maybe this is some API that you've got or any service. And they're exporting using pre-built SDKs. So, Go, Python, Scala, there's several others, Java, Ruby. You're exporting some metrics about your service that are important to you, that you want to know about. So with these SDKs, it's pretty easy to get started exporting metrics in the Prometheus format. And as long as Prometheus knows about those services, it'll ingest them, no problem. Now, there are some pre-built exporters for you. Some that we use are Zookeeper and Kafka. Our data platform uses Kafka as the messaging bus, so that's a pretty important one for us. But you also have CAdvisor and Node Exporter. So CAdvisor gives you information about Docker itself and the containers running on it, and Node Exporter gives you information about the nodes, like CPU, memory, file system usage, stuff like that. So, you may have to write some of your own custom exporters, but there's a huge list of things that will get you going right away with services that you probably already use. And that's basically it. So you have Prometheus backed by a volume ingesting whatever you tell it about, and then you're visualizing it in Grafana with maybe some alerts on top. So it's not all, rainbows and sugar plums. There are some challenges associated with rolling your own stack, as is to be expected. If you're running one Prometheus, that's a single point of failure, which if something is going wrong and your Prometheus goes down, well, that's when you want it the most, right? You want to know what's going wrong. And if you're only running one Prometheus, then you have a pretty high chance that you can lose that one. And you're responsible for these failures. So when Prometheus goes down, you have to fix it. There's no one you can call. You're the guy. You're the one other people are calling to say, hey, what's going on? Where are my metrics? Where's my dashboards? So you're responsible for any failures that occur. And these things require maintenance. So how are you going to manage state across different platforms? That config I showed you, how are you going to move that from your dev environment to your staging to your production environment? And are they the same? So you have to think about how you're going to manage that. And of course, you need to keep up with versions, security patches, things like that. So how are we going to fix some of these challenges? They are fixable. We look to Thanos, which is a companion to Prometheus. And I'll jump to the next slide because it has the same words. Here's a picture that I'll explain as I'm going. And it provides long-term storage. So we're using S3 here to store the metrics that Prometheus is ingesting. Thanos runs as a sidecar to Prometheus. And after 2 hours, which is the compaction window, that's when it dumps the disk, Thanos will say, okay, I'm going to take the block of metrics that you just wrote or are going to write and send them to S3 as opposed to a disk. We still run with a disk just in case anything happens, in case that link to S3 is severed, but you could potentially run stateless if you were required to do so. So yeah, Thanos also does high availability and deduplication. So this goes back to running one Prometheus. Now you can run two. Thanos will load balance between the two servers. Say, okay, you want metric A, well, I'll go and find metric A from either whichever one has it, you can shard, or we're running such that both Prometheus scrape the same thing. And that's because if one goes down, then the other one has everything as well. So And they both run on different nodes, so there's less danger of both of them going down. Thanos also handles some bucket operations, so you can downsample after a certain period of time. Say after 1 week, you're not necessarily cared about 1 second granularity, you can up it to 5 seconds, 15 seconds, whatever you think makes sense for your use case. And you can eventually mark series for deletion. So if you need to be efficient with your space, you can say, after 30 days, after a year, go ahead and toss out those old metrics that I don't need. And we're doing this across several different systems here. So you have, in this case, dev, test, and prod. So this setup is duplicated across different environments. So going back to what Fiodar mentioned earlier with the control plane, we would like to have all of these different environments visible in one place. So what we do is we take dev, test, and prod. The information that is coming out of them from Prometheus and Thanos are friendly gatherers of metrics. And we ingest them into our control plane, which we run on Kubernetes. And there right now we have the simple setup that I showed you. So we're scraping services in the control plane Prometheus, as well as ingesting the other platforms that we need to know about, our data planes. And we're visualizing them in Grafana. So this is a pretty portable setup. It'll work, I don't want to say anywhere, but nearly anywhere at least. And it gives you a nice top level view in this control plane. You can see what's going on in dev, what's going on in test, what's going on in prod. Are there problems across all of them? Are they healthy? Or is there only an issue with one of them? We can see that from this control plane. And so with that, I'll go back to, using a managed service may suffice. If you don't have these requirements, then maybe the managed service will suffice. But if you do, you can, hopefully I've shown that it can be fairly simple and powerful. And I think with that, we'll open it up for questions. And if you'd like to get a hold of us, here's our website, our emails. We'd love to hear from you.
Thank you so much, Kiefer. Thanks, Fiodar. As Kiefer said, the floor is open for questions, so please feel free to unmute yourselves, or if you're more comfortable, you can put your questions in the chat box. Thanks for providing the best way to contact you guys. That's great. And as a reminder, this presentation was recorded, so it will be on Riot's YouTube channel and on our meetup page. And the actual presentation itself will be shared as well. We'll give a few minutes for questions. Klarrio also did a wonderful presentation for Riot's Developer Month, so you can also find that on Riot's YouTube channel as well.
So while people are thinking of the questions, Kiefer, can you show the next 2 slides really quickly? So that will be in the PDF version. If you're interested in how you get started, how can you run the Prometheus and the Grafana setup? Really simple, the most simple. There are some instructions that you have to have a Docker. This is one file, you create one file, another file, just as is. And you run a few commands, go to Grafana, log in, and you can create a dashboard. It'll take you, I don't know, 3 minutes, maybe 2 minutes. So this will be in the PDF file as well.
Thank you so much. Have a quiet audience today.
I did have one quick question. I haven't run into Prometheus in the past. I've used InfluxDB in the past. I see Grafana integrates with that as well. I don't know, do you have any high level comparison in your mind between Prometheus and InfluxDB that might be useful for us?
InfluxDB is a very good product. We would probably love to use it, but the commercial use and licensing is basically preventing us. We mostly build out open source, And I forgot the specific items, but so we would like to use InfluxDB, but it's a commercial product that didn't work for us.
Right.
So-
And I can see Prometheus offered those scraping interfaces, which are not part of Influx at all. So I guess that's a feature that would be missing. Influx is just a database, whereas Prometheus seems to have that scraping feature.
Yeah, so Influx, it's very good, very powerful time series database. So you could, store the data in there, I'm pretty sure, and run kind of different analysis. Grafana should be able to pull it from that. I don't remember how you kind of get your monitoring data into Influx. Again, there are other, Prometheus is not the only game in town. Grafana is actually, I think, a part of a suite that there's Graphite, a sort of competitive metrics ingestion system, so they may work with InfluxDB. What Prometheus, it seems to be like everywhere you look at, everybody's running Prometheus. At least that's what it seems. The nice thing about the scraping approach, the other thing is, in many components, open source at least, you look at them and they say, yep, we provide Prometheus endpoints. Right? Nice thing is, they don't care if you run Prometheus or not. They don't have to push anything anywhere. You run your Pulsar, Kafka, whatever, and let's say they have Prometheus endpoint. If you don't call them, well, no harm, no foul. So it's the pull model is nice. You don't have to worry about the back pressure, right? If it's a push model, whenever there is a push, you need to think about back pressure. Too many people pushing into too narrow of a hose. With a pull method, Prometheus will get to scraping whenever it can. So it may not be 15 seconds exactly, but usually it's fine. So I don't know if how well I answered your question.
No, that's all very helpful. Yeah, it wasn't that's good. My question wasn't about anything in particular, just always good to know the wider field of solutions out there.
InfluxDB is, if it was like Apache license, or that'll be awesome, but they want their money. Can't blame them.
Thanks for the question, Tony. All right, we still have a few more minutes if anyone has any other questions. All right, well, if you're more comfortable reaching out to Kiefer or Fiodar personally, they did provide their email addresses, or you could reach out to the info.usa@klarrio.com. Oh, we have one here. Why is the open source version of InfluxDB not an option with Telegraph to ingress the data?
It probably is.
Dude,
I'll say that.
may be an option. Why exactly we did not use that? It's been a while, so I remember looking at the Telegraph and at least for ingestion. Yeah, I guess it is. If it works for you, fine. You don't have to use Prometheus. Again, from the license perspective, in general, in open source, you see it more and more often. People try to basically protect themselves from AWS hosting their open source technology and charging money for that. So, what is it? Kafka, Elasticsearch, Mongo, I think, others. If you use that, it provide as a service, you have to use, I think, their own license. You have to buy the enterprise license. So open source InfluxDB license may not be Apache, where you can just go ahead and use it. And it may put some, again, does it put restrictions? I don't remember. It might. So it could be, again, sometimes if you're using open source component just for your, let's say, enterprise, it's one thing. But if you build a platform that you provide it's part of a platform that provides some services to the public that may be different things.
Thanks, Fiodar.
And sometimes, well, you picked one over the other. I don't know. I like it better for some reason. Sometimes it's that.
Awesome. Well, thanks so much, guys. We appreciate your time. And please do visit them at Klarrio.com or reach out to them personally, add them on LinkedIn. Thank you all for being here. We'll see you next time. Take care.
Thanks, everyone.
Thanks.